let's understand the standard deviation of a data set. So standard deviation, oh, come on, buddy. Standard deviation is, it describes the spread of data. So a large range, right, the larger the range, the more spread out the data is, that means we have a larger standard deviation. Whereas the closer together your data is, right, so if it's all bunched up, it's going to have a smaller range, right? Remember, range is max minus min. So if we have a smaller range, that means our data is closer together. That means we have a smaller standard deviation. So it's nice that those things kind of go together. And I know that those numbers are hard to quantify, like what's larger, which smaller, and it kind of just depends on the data, right? So let's go ahead and jump into this. If we're looking at the data graphically, which is how we're going to do it here in this video, I have here, these are not histograms, these are bar graphs the way I drew them because the bars do not touch, but that's okay. A histogram and a bar graph are going to work the same way in terms of talking about standard deviation because they're bar graphs of a type. Now you can see in graph A that we have, it's kind of bunched together. We have a bar that's obviously higher than the rest, but because these are kind of, I would call these more bunched than in B, where you can see they're more spread out. Okay, now it's easy to do if you're comparing to, like I can look at these two and say, yes, the graph on the left only has 5 bars and the middle one is obviously higher than the rest, and it's kind of symmetrical, right? Where the higher bars in the middle and they go out on the left. But when I look at B, there are 7 bars. They're all pretty close in height. I mean, there's differences, but they're pretty close. But it's spread out along the horizontal axis a whole lot more. So we would say this one has a larger standard deviation just by looking at it, right? Where the bunched ones have a smaller standard deviation. Now, it is possible that you have outliers, and if you would have an outlier, so let's say in graph A, I would add this little outlier way out here. Because this number is so far out there, it will skew the standard deviation. So just be aware that outliers can impact the standard deviation. Okay, now let's look at box and whisker plots. So remember that box and whisker plots are created based off of the 5-number summary. So again, thinking about number lines, if we have number lines underneath each of these box and whiskers, you can see clearly that the box and whisker on the left, which is really only about, I don't know, maybe 2 inches long, whereas the box and whisker on the right is like 5 or 6 inches long. Very, very different in terms of range, right? The box and whisker in B has a much larger range because it's like 6 inches long. And we know that the 2 ends of a box and whisker are the min and the max, which is what we use to find the range. Whereas in A, it's only 2 inches long, so that's going to have a smaller range because the max and the min, right, the ends of the box and whisker are a lot closer together. So because of the smaller range, larger range, we know that the larger range means a larger standard deviation, and a smaller range means a smaller standard deviation. Now that's it looking at it graphically. If you're looking at numbers, it's not as easy to identify, but you can still look to see your range. If you have a huge range, you're probably going to have a larger standard deviation. Now, we can estimate the standard deviation by using the range rule of thumb. Now, I want to throw out that this is an estimate, right? This is not an accurate way to do the standard, to calculate the standard deviation, and it only uses the max and the min. Therefore, it may not be even close to accurate. But if you just real quick need to know, like, what's a general ballpark, this is a ballpark thought process, okay? So we would say the standard deviation can be estimated by taking the range of values and divide by 4, okay? But remember, this is an estimate. We're only using the max and the min because the range is max minus the min. Okay, just want to throw that out there. So let's just do one of these, estimate the standard deviation using the range rule of thumb. So I have a set of data here, 8, 17, 12, 34, 16, 31, 24, 36, 7, 39, and 14. So to use the range rule of thumb, I need the max and the min so I can find the range, right? So when I look at my data set, the max, the biggest number is 39. The smallest number is 7. So to estimate, again, estimate the standard deviation, I would take 39 minus 7 and divide by 4. So 39 minus 7 is 32, and 32 divided by 4 is 8. Okay, so we estimate that our standard deviation is 8. Just letting you know that when I calculate this as a sample standard deviation, I get 11.7. So you can see 8 compared to 11.7, I don't know, might be kind of close, might not. So that's what I'm saying. So the actual is 11.7 for the sample standard deviation. So this is definitely just an estimate. Pay attention to that. Okay, thanks.